We're here at the Nagagami Carbonatite Niobium and Rare Earth project for Noble Minerals.
The good mineral, the niobium and the rare earth minerals are in the magnetic low, surrounded by a magnetic high.
This is a project that was picked up by Wayne Holmstead, who identified this carbonatite being very similar to that of the Niobec Mine in Quebec. And it had been totally unexplored in the mag low portion of the carbonatite, whereas in the early days back in the 1960s, Agoma Metals had been looking for iron ore in the magnetic high ring around the anomaly. What we feel is that there's a potential here for niobium and rare earths. And niobium, as a result of a sample that was taken from a drill hole done by Agoma Metals, it was a grab sample taken out of a core, I think it was around 200 meter in depth, that ran in the order of 0.3% niobium pentoxide. Now, niobium, as everybody may well be aware, is an extremely important critical mineral, and we got to be able to secure a supply line that is responsible for not only the niobium aspects of the steel industry, but also the rare earth aspects of the greening economy.
I first came across the Nagagami project when I was doing research for another project that we had, the Boulder project, where we're trying to trace the origin of a very rich boulder that was found just south of Hearst. And in doing research for the area and also my experience working in Quebec, I realized that we were looking at a carbonatite here, and it had a very unique magnetic signature. In 3 dimensions, it looks like kind of looks like a donut, and the good mineral, the niobium and the rare earth minerals are in the magnetic low, surrounded by a magnetic high. We realized that the Nagagami project had very similar characteristics, and in the past there had been some work on the project, mostly around the magnetic high, that indicated that it was a carbonatite, and so we decided to stake claims here and explore for niobium and rare earths. We plan to drill 3 holes here, spaced roughly 500 meters apart, to intersect the magnetic low. We're drilling down to roughly 650 to 700 meters. And we're going through about 100 meters of Paleozoic sediments on top of the carbonatite, but after that it's all carbonatite, and it all will have the same potential for niobium and rare earths. The reason that we're drilling vertically because there's been very little work done here in the past. We didn't know how thick the Paleozoic sediments were, so I figured by drilling a vertical hole, we'd get into the carbonatite sooner. And once we have an idea of what kind of structures we're dealing with, and then we can drill some angle holes. And when we know how deep the Paleozoic sediments are, we'll have a little bit more information so that we can more accurately target the mineralization.